Okay. Hello, everyone, I guess. My name's Dave Garchin, and I've been doing this for, seems like most of my life here. I mainly do the Hubble palette is what I'm more interested in. So, and I got this one other one here. Showed my first Elon one there, I guess, or there we go. This is actually my first and last picture, final, but how many seen the Starlink change? Well, I just said, I think Elon owes me 10 minutes worth of Starlink time. How much does he make in 10 minutes of time? I think he owes me that because that's what this image did. I got 24 satellites in one picture, one 10-minute sulfur shot. So, damn you, Elon.
I copy Starlink because they're all on the road.
Well, I did get a one random one up here, but that's the only one I can think of. But I never had so many satellites in one shot at all. Okay, I guess I can get to the next one here. Okay, good old favorite, the helix here. This is actually a very small nebula. I'm actually cropped way in on this one. I didn't get a whole lot of good detail inside the nebula because I'm only shooting 530 focal length. So if you got a little more focal length on, you get a little more granular in the center of it there. But I was happy with it. I got, let me see here. I had a total of 23.25 hours on this. I took 15-minute subs. I got 40 HA, only 15 on the oxygen and 38 on the, what is it, the sulfur. So, but it's a kind of a hard one to shoot it for. It's low to the horizon. You don't get a whole lot of time on it, and you just take what you can get on that. So it's a pretty bright nebula for as little as it is. There's a lot of oxygen in there. I think that's what lights it up the center of it so much. So I was pretty happy with what it turned out for what I got on it. Okay, the next one, Richard. Okay, here's the little rosette. Did you ever see that one, Mike? Okay, well, okay, this one on the right, NG7822, I took a full picture of that last year and showed this. And this is when I found out the little rosette was right next to it. Well, my next year, I'm going to get the little rosette over there. So I got this, and I'm starting to think there could be a physics paper in this for you, Mike. I think these things may have been combined together at one time. From my last year's previous picture, I'm going to show here next. I got this little object right here, this little peanut thing pointing right at the rosette. Okay, my next picture, I got this whole nebula, and it's from here over. You can see this little L thing, which kind of points towards that. So, getting the whole big picture of this thing, and to me, I think this is like a cosmic cannon almost. So. Go ahead and flip to the next picture there, Richard. I showed this picture last year. Here's that little nugget, which is pointing right over here to the little rosette. So it's just amazing. I said that it looks like that could almost fit in there, and it got shot out of there. That's just my gut feeling of it, but it could have been one nebula at one time. Yeah, this is all the Hubble palette. Yep, NGC 7822. And this one, I had used 15-minute exposures. I got 32 HA, 29 oxygen. Oh, no, that's my other. That's the little rosette I'm talking about. I was talking, that was a little rosette on these, and 50 of the sulfur on the previous one. So I thought that was an interesting 2-year adventure for me. And I'm actually starting another 2-year adventure one here. I have a couple more pictures here. In fact, the next one here, yep, IC 2177, the Seagull Nebula. I got a total of almost 40 hours in this one here. I got 80. Okay, I took 7-minute subs. I got 84 HA, 99 oxygen filters, and 100 sulfur, with a total of 39.95 hours on this. And this is my first picture that I divorced sequence generator on. This was my first picture I used with the ASI Air Plus, and it was kind of my learning picture. But the ASI Plus is just awesome for me. I just can't believe how easy it is to use. I'll never go back to sequence generator. Sorry, Pete, but but yeah, and also my next year picture, while taking this one, I found out down here, just off here, is Thor's helmet. So I'm going to go after Thor's helmet here, and then when it comes around next. So this is usually the last nebula of the year here. And I said I got 30, almost 40 hours into that one. But I was fairly happy with that one. And then, okay, my last one here. This is actually my longest picture I ever taken. And I actually took 3/4 of the data down here in Portage, and then we had the Garten getaway up north, and I got about 1/3 of the more data up there. I had a heck of a time processing this picture. I just couldn't get it right, it seemed like, but I just went on the internet and tried to see how the other guys are doing it, and I found a couple of them that said that's what I want. And I think what I'll do next time, what I found out that the other pictures did, they did half-hour subs. I only did 10-minute subs here. And I got a total of 51.5 hours on this. I got using 10-minute exposures. I had 107 HA, 111 oxygen, and 92 sulfur, all 10-minute exposures. And that is NGC 6823. It kind of reminds you of the Eagle Nebula a little bit down there, but it's very dim as far as astrophotography wise. It's right up in the middle plane of the Milky Way in the dark lanes. And that's why I'm thinking I should just go half-hour subs on it instead of 10-minute exposures. Because the other two that I saw, they said that's what they both had, was half-hour exposures. So up there in the dark lanes, go long on exposure time for narrow banding. So, and that's it for my venture in astrophotography this year. Thank you.
Dave, were all these up at the dark sky site?
No, this one basically was part of it only. The other ones are all taken at down in Kalamazoo. Takahashi 106. It's the only thing I shoot through. Maybe the 120 refractor or something.
All right, thank you, Dave.
Yes, this one is, of course, very recognizable. Orion Nebula and the Horsehead Nebula. There in one shot. That's taken with a little Red Cat 51, and it's 165 minutes. What I really like about this is the same way Dave Garten was talking about his cannonball, those nebulas being, maybe at one time the same nebula. I always like to look at the Orion Nebula and the Running Man. I think this picture shows it quite well that, there is something obviously bright happening in that dust cloud, and we've got that dust lane that crosses over right between Orion and the Running Man. So that's why I really like this photograph. And of course, the horse head's in there as well as the flame. Got quite a few items in there, all different catalog items, but obviously part of the same process, the one object going on there. This is my Trifid Nebula this year, just a single hour. But the Trifid Nebula is always one of my favorites because it has the three types of nebulas on display there. emission, reflection, and dark nebula types, all right there in the same display. This is the Triangulum galaxy I was able to do this year with the Red Cat 71 and the ASI 2600 camera. This too is about 55 minutes on this one. Another picture in the south, the Lagoon Nebula and the Triffin Nebulas together, M8 and M20. This also was made with the Red Cat 71. It's a 350 millimeter focal length refractor. This is just over an hour at 85 minutes. This is an hour on a very well-known object, the M1, of course, the Crab Nebula. I always like the tendrils that you see around that object. This is with the RC 8-inch at 55 minutes, actually. This is a wide field, 250 millimeter focal length of both the Heart and the Soul Nebula, IC 1805 and 1848. Always fun to show this one at public observing night. The Heart and Soul being right next to each other in the sky like that.
Is that a mosaic, Dave?
No, this is just one shot at 250 millimeter focal length. This was I had both my telescopes, the 8-inch Ritchie Chrétien and the 71 millimeter Red Cat, both focused on the Iris Nebula here at the Garden Getaway. So this is the view I got with the 8-inch at 1620 focal length, and I believe that is 9 hours. Really brought out the dust that surrounds that object, and the wide field view through the Red Cat 71 really brought the dust out, really brightened up all the dark material that's in that part of the sky very nicely. So that's at 350 millimeter focal length, and those two were the result of the Garden Getaway this year. And that's what I have.
Thank you, Dave.
Okay. This is my observatory in the backyard. I did landscaping this year, so I just wanted to give you a quick look at how things are right now. The next phase is going to be to plant the garden up against the fence. That'll be next spring. Now, let's move into the astrophotography. This is a picture I first showed last year. I brought it back today because I told you last year that I really wanted to go back to this site to photograph the Milky Way from the other side of the observatory. So this year I did. And my slide did not, there we go. Here's my setup. I've got the telephoto lens on my Nikon camera body, a tripod, and a chair to sit back in because it's going to take a little while to do this. Where the exposure information is set up on my screen right now, I can't read it because there's a bunch of little boxes with names and with views from the screen that you've got over there in front of you. So you're going to have to read that for yourself. But it's typical of the settings that I use for doing these nightscape photography images. And there's the Milky Way over Yerkes Observatory. I went there on exactly the right night because there were fireworks going off and it kind of lit up the dome with a reddish glow. Speaking of Milky Ways over observatories, here's the KAS Owl Observatory with the Milky Way over it out at the Kalamazoo Nature Center. My technique is to shoot a lot of pictures of the sky and usually 1 or 2 pictures of the ground and stack the sky and blend the ground in with Photoshop. From that site, it was a night when I was testing my new GTI Sky Tracker mount, which I had never used before. And I got it out and I set it up and I said, well, you know, it's first time I'm using this. I think I'll go with kind of short exposures. I cannot read what the exposure length is here, so you'll have to read that for yourself. And this is the North American Nebula, same night, same place. The star Deneb is up there in the picture, kind of a third of the way down over on the left-hand side. What I'm trying to do is get a little bit better at composing these pictures. This is one that I took a year ago, and I explained to you then that this is not really the picture I went out to take, but I couldn't get out on the pier out to that little green light out there to take the photograph over the lighthouse. So I would have to go back. Well, I went back. I decided to try something different than doing lighthouses or observatories. I decided the covered bridge down by Centerville would be a good target. And I went down there and found out that the only place to photograph the Milky Way behind it from is on the other side of the river. That presents a problem because the Milky Way is huge and the bridge gets to be looking kind of small from the other side of the river. So what I did was I took my stack of pictures, found one that had a car that drove down the causeway and around the turn into the bridge and lit up the bridge. So it made the bridge a little bit more of a focal point, just kind of made up for the fact that it's so tiny. This year I went back up to Isle Royal, and this picture was taken on a little trail. There's a camping lodge up there. I stayed in one of the cabins off in a different area, but I went around the edge of the camping lodge down a small trail that went out to a little rock point. And where I set up was about 60 feet above the water level. You could hear the waves crashing on the rocks down underneath. There were trees coming up the banks of the hill. So they're my foreground trees. And you could hold your hand up in front of your face at that point and not see your hand. It was that dark. So I took a stack of pictures of the sky. And if you look at the foreground exposure, you'll notice that it's kind of a long exposure in comparison to the sky exposures. They're fairly short, 25 seconds or so. The foreground exposure, I had to burn that image in for 10 minutes. Also at Isle Royal, I set up the tracker and did some medium telephoto images from there, including the heart of the Milky Way with the Lagoon Nebula, above it, the Trifid Nebula, way up at the top, the star cloud M24, and a few other things in between. One thing I like about this particular picture is it shows off the reddish coloring of the core of the Milky Way and the bluish coloring of the stars in the spiral arms. And I also took a picture of the North American Nebula. It doesn't look as intense as the one that I took out at the Nature Center, but that's because the sky was a lot darker and I didn't have to run quite as long of an exposure to get the image to show up. Rho Ophiuchus complex, I like this one because of the multiple colors in there. There's the yellow light of Antares reflecting off of some cloud, so it's a reflection nebula. There's the M4 globular cluster, which is next to Antares, also yellow in color, but it's yellow for a different reason. It's because it's behind a cloud of dark material, which is reddening the light a little bit. Then there's some blue reflection nebula, and then there's the dark nebulous that trace back toward the edge of the Milky Way. I got permission from the people who run Old Mill Golf Course down on, well, south of Schoolcraft, to go out there and take some pictures of the Milky Way at the golf course. And I decided I better get one of the clubhouse for them to hang on their wall. And this is the picture that I really went out there to take. There's a little pond out there and a small bridge that goes across it. I wanted to get the bridge and the little roadway that leads up to the T down there, and the Milky Way behind. If you go much farther south, you come up to an open field and the sky just brightens right up because of all the street lights down south down there. May 26th, there was a session that the KAS held out at the Nature Center, but I stayed in my own neighborhood and did a star party for people in my neighborhood. And I kind of like doing that because it helps them to appreciate what my observatory is about. It helps them to know what's going on inside there, that I'm not peeking through their windows or anything. And when the last people left, I decided, well, since everything's all set up and it's pointed at the moon and I got a good sharp focus and it's a steady night, I think I'll see how sharp of an image I can get. This is the final result. The blue supermoon rising over Westnedge Hill. To get this picture, I went to the Maple Street School for, well, it's something about the arts. And from the upper level by the cafeteria of the school, you're looking down over a double hill that gets down to a football field underneath. And that football field is where my grandfather had his first celery field. The street light that you see kind of in the lower middle of the picture is on Westnedge Hill as you're going up the hill. And beyond that is Crane Park with the moon rising. And I like this picture because it shows the changing color of the moon as it gets higher in the atmosphere. The way I took the picture was I had an intervalometer that was taking a picture once every minute. And I threw away the pictures until I got the first one that was completely clear of the tree line. And then I took every third picture after that. So there are 3-minute intervals between pictures. This one you've already seen. No, you saw this one's partner. This one has Jupiter and Venus near the tip of the tree branch that sticks out the farthest. The reflection of that down in the water. And if you can see a little ripple in the water there, and it bends and comes back a little bit, that's a beaver swimming in Asylum Lake. The planet Mars went through the Beehive cluster on June 1st. 2 weeks later, the planet Venus went through the Beehive cluster, but the sky was a whole lot brighter then because sunset was later, and because everything had moved a little bit closer to the sun during that time. So I couldn't get Venus and the Beehive cluster in a dark sky. Okay, left-hand picture was taken before the supernova. Right-hand picture was taken after the supernova. Look carefully. Can you find it? It is in the upper left corner. There's a little line of 3 stars. And if you look down at the bottom star in the line, there's a big bloated star that covers it up in the other picture. So there was a nice supernova in M101 earlier this year. Then do the observatory pictures. I use M27 as kind of my reference object for getting the camera focused, making sure that I'm tracking well, and I'm also using it as my practice object for doing the narrowband filter imaging. Narrowband filters are giving a lot sharper of detail within the outer parts of the nebula. And you've got all the information. Basically, when I do pictures from my observatory at home, the sky is bright enough that I am limited to about 1 hour total time. So I'm taking a series of 5 reds, 5 greens, 5 blues, or 5 hydrogen alpha, 5 oxygen, and 5 sulfur. And I got a bunch of other planetary nebulas. I like the little bitty one of the Little Ring or Diamond Ring Nebula. It's up in the constellation Cygnus. The Owl Nebula I've done with my telescope at home, and I've also done the Owl Nebula using the KES telescope in Portal. This object kind of looks like a planetary nebula or maybe a supernova remnant. It's neither. It's a Wolf-Rayet star that's expelling a cloud of gas. It's a very young star rather than a very old star. And this is what it looks like with narrowband filters. By the way, where it says blended and adjusted in Photoshop, you should add the word "and a little bit of magic." The Cocoon Nebula, I like this one because, again, you're getting a mixture of colors. You're getting the reds of excited hydrogen gas. You're getting blue of reflection nebula. I didn't mean to do that, so I'm going to back up for just a second longer. And you got the dark nebulosity region at the bottom where you're blocking the light of the stars that are farther away. Now we'll go on to this one. I don't even know the common name for this nebula. I just know it is 6823. I have tried photographing it with the red, green, blue filters. I can't get anything to come out of it. It's just too dim. But when I used narrowband filters, which I thought narrowband isn't getting that much light, apparently I found the proper gain settings for working with narrowband because I was able to pull a fair amount of detail out of it. And my last picture here is M16, the Eagle Nebula. I kind of like to think of it more as a dragon. Look at the head that's coming down from the top and the claws that are coming out at you. And there's my set for this year.
Hello, my name's Greg Shanis. I came into the club. I live in Sarasota, Florida, and I came into the club from um, the during the COVID lockdown. I heard of the club, and I was listening to the lectures online, and I subsequently became a member. And I took Richard's Bell Amateur Astronomy course series twice, actually, because the first time I missed one. But the second time I got the certificate. But I'm into planetary imaging, and I want to go over all the planets. Mercury is one of the hardest planets to image. The best time to do it is when it's rising in the morning. And I submit all my observations to ALPO, the Association of Lunar and Planetary Observers. And and here, Frank Melillo is the Mercury section coordinator. And here on July 4th, 2022, I got a really nice image of Mercury. And Frank was kind enough to find different craters and planitia and everything and labeled it. Here's a messenger image, a messenger spacecraft that visited Mercury, and it's shrunken and blurred a little bit to match my observation. So, and only 26 degrees latitude. And then Venus is very bland in the visible, as you know. The only exciting thing about it is its phase, but in the ultraviolet and infrared, it shows cloud features. And in the May 2023 Prime Focus, I published an article entitled Seeing Venus in a Different Light. And I was also a featured speaker at the 2023 ALPO conference on July 29th, day one. I'm the third speaker in, so check it out on YouTube. And here, this is very important when you can get simultaneous images. Here, April 17th, this was taken by an observer in the United Kingdom, Martin Lewis. He has an excellent website called the Sky Inspector. And there's hstjupitergroups.io, which is run, webmaster is Chris Go runs it, and observers from all over the world upload their images there for archive and professional amateur collaboration, which is really cool. So check this out. You wonder sometimes, are these features real? I mean, this looks like three-dimensional here, right? And then notice this was taken all the same day, 19 hours, 9 minutes. And then Alberto Sequez, who's a friend of mine, Lutz, is right near Tampa. He's only about 75 miles north of me. And he took this image about 4 hours later, 22 hours, 17 minutes. And I took it about an hour later, 23, 15 minutes. And notice Venus moves westward as it rotates. And notice these features right here are at the meridian. And then when you look at it 4 hours later, they shifted to the left. And as you look at them here more, they shifted closer and closer to the terminator. So that tells you that these features are real because they're rotating with the planet. Isn't that fantastic? I mean, it's really great when you can get something like this. And I put this together because I noticed that Martin Lewis had the same one that Alberta did, the same one I did on the same date. So I put all this together and uploaded it. So it was, and everyone was really glad to see a simultaneous, 3 observers the exact same day, just a few hours apart. Okay, and then Venus and upper atmospheric clouds. The clouds appear darker because there's an ultraviolet absorber on Venus. And so the upper atmospheric clouds appear dark, and in infrared wavelengths, the clouds appear dark too, but these are mid-latitude clouds. And you can use a ZWO 850 nanometer filter as well as this one, works just as well. And now on to Mars, visible and IR. You want to use infrared when you can because it stabilizes the atmosphere. So a lot of deep sky images for the luminance file actually use an infrared filter. So you get a much steadier image. So here's just some of the different albedo features of Mars here. And then Jupiter, visible and IR. Look at that image of Jupiter. Usually you don't get it that nice. And here I derotated at 10 minutes with WinJupos. And derotation is when I take 10 60-second videos and then align and stack them in registacks and then sharpen. I mean, in align and stack in auto stacker and then sharpen in registacks and then I put them in WinJupos and it aligns all of them together. So it decreases noise even more, increases signal even more. So it's really nice. And I love shadow transits. I'll always get up in the middle of the night to see a shadow transit. I love them. And then here's visible, here's infrared. And then look at this. In the methane band, you're seeing, oh, one thing I need to mention. This is kind of the baseline cloud features in the visible. The higher you go in the infrared, the higher cloud features you're seeing on Jupiter. So these cloud features here are higher than these. And they're higher still in methane band. And one thing about methane band is this looks exotic. This does not look like Jupiter. I mean, Jupiter looks like this. And now you're looking at this. This equatorial band, zone. Look at it. It's just so bright in the methane band. And look at this. This is a Hubble. I mean, this is a Webb near cam image at 1,000 nanometers, and I'm at 889. So I'm pretty close. And look at this. It looks very much the same. You got the equatorial band here. Look at the red spot, and then over here, all these features down here. The only thing I don't have are these auroras way up there. You see those auroras. You don't see them on Earth, but it's just fascinating how, you know, this matches the Webb image. And then, oh, I didn't include the Jupiter and the ultraviolet, but oh well. And then Saturn shows this Zeiliger effect, which is during opposition. You always want to observe at opposition. The rings get actually a lot brighter. And now that the rings are becoming edge-on at Saturn, you're actually able to see shadow transits on Saturn. So look at this. So here, this is a shadow transit of Tethys. And here's the moon, and then there's the shadow. See it? Can barely see it. It's very, very hard to see, but I had a really good seeing here. Can you all see it, I think? And then notice how bright it is, and then it's even brighter in the visible. See how bright those the rings are, and then look at it here. See, they're nowhere near as bright. So that's kind of neat. That's the first time I've experienced that. And then this image I love because this image I took of Saturn 2 days after Category 4 Hurricane Ian hit the Gulf Coast of Florida. And it actually hit Fort Myers, which is about 70 miles or so south of me. And I got hit by a Category 2 hurricane, and it took down one of my fence. So I did get some damage, but overall, I went through it pretty well. But look at this, just 2 days later, look at the scene. I mean, you can tell one of the nice things is look at the Enki division. You can see it all the way through. That's one of the nice indicators of excellent seeing. See, on some of these others, see, you don't see it as well here as you do. See. So that's a good indicator. And the Yankee division is even harder to see. But and then this is my magnum opus. I was able to image 6 planets in one night. The only one that wasn't out was Mercury, and Pluto's no longer a planet. Plus, it would just be a die. So this was really great. It actually happened on October 10th, because October 10th at 8 p.m. Eastern Time is 0 hours, midnight the next day, Universal Time. And Universal Time is all that counts. So really, I took 2 days to do this, but in Universal Time, it's only one day, and that's what really counts. So here I did it at 8:07 p.m., 9:08. This was 8:07, 8:54, 9:08. This was 11:49. Now it's the next day, the 11th, 12:30, and then here it's about 7:18. And notice Venus is very bland in the visible, but look how nice the planets came. It was a really nice night of seeing. You can see the nice polar vortex there, and you can see the Cassini division all the way around. And notice how the rings have shifted too. See? And here you can see the North Polar area on Uranus and Neptune. And then here it is in the infrared, except for Venus, which is in the ultraviolet. You can see the clouds. So that's it. So any questions? I hope you guys are just masters of deep sky imaging. I hope you get into planetary. It is so much easier and just as rewarding, and you're actually doing real science by submitting these to professional planetary scientists, and they're using our data. And if there's something really, funky going on Jupiter, they'll turn the Hubble Space Telescope and the Webb to see it, and amateurs caught it first. So you're really doing very valuable science by imaging the planets.
Okay, so this is my efforts for the year. This is my current setup. Compared to last year, I've upgraded my 12-inch Newtonian to a carbon fiber tube, which at this time last year I had just ordered from a gentleman in Germany who's been making carbon fiber tubes for many years. You can get them any size you want. You can get them as replacements for commercially made ones. Very reasonable. It takes a long time. So I got it like in March of this year. So it took about 6 months. So it's a 12-inch f4 Newtonian. I upgraded to a Moonlight CRL, which is a 2.5-inch focuser. The main reason I went to that focuser is the draw tube is threaded, so there's no compression rings. When you put compression rings on camera, sometimes they tilt, and when you're at f4, it starts becoming more of an issue. So everything in this image is threaded on from the camera to the filter wheel, which are bolted actually together. These are a QHY, which is what I used last year. Same thing with the off-axis guider, and then it goes into a Teleview Paracore Type 2, which is great coma corrector for visual and for astrophotography. It does multiply it a little bit by 15%, so it's not f4 anymore, and it's about 1400 millimeters. A very solid setup. Been very happy with it. I'm still kind of tweaking it out. I was busy all summer since the boss at home had me doing remodeling, so I pretty much had a big gap for most of the year not doing much. And this barely fits inside my 2.4 meter dome, a little 8-foot next dome. Go next. So the first image that I took pretty much right after last year's Astrophoto is M1 up in Taurus. It's one of my favorites, the image. I always do that to see how I improve over the years, and I have a whole stack. Well, maybe next year I'll bring my progression over the last 20 years of M1s. They go from what you see in an eyepiece, basically a nice cotton ball, to this one. almost 13 hours of exposure time. I used H alpha, which is most of the little tentacles and all that stuff, are all the reddish parts are very prominent in H alpha, and then the rest was LRGB. I really blended the H alpha and luminance together. I typically run my camera about -20, but I'm finding that it's hard to hold -20 in the summertime. And with the CMOS cameras, there's so low noise that I can probably keep it at -10 year round and not have to worry about it ever again. But anyway, 1600 gain. I know people mess around with gain and stuff. I kept it there because I knew that was, someone recommended it, and it's Unity gain. So I'm really happy with this one. I did shoot some 03, and you can see here on the left side, there's a little bit of a out shooting here. In the 03, there's actually more, but I just didn't get enough exposure to really add it to this. Okay, next. Monocaros. Yeah, this is up by Betelgeuse, up actually to the left of Betelgeuse when you cross over up into there, about that area of the sky near the Cone Nebula. This was a little over 13 hours. Good representation of the types of nebulas that are out there. You got reflection, you got some emission nebulas in the background, lower right, mostly the red. You got lots of dust. It's really neat with these mid focal length telescopes around 1,000 millimeters, because you can point them almost anywhere and pick up like this more zoomed in areas of more famous objects and get all these nice little details. Oh, just for Mike, go back one. I want to put that one in his face. So there you go, Mike. M1. Okay. Thank you. I just wanted to hear that. So this was a really cool one. I like this area. Then the clouds came in for the winter and I had to stop. LRGB, I'm pretty enjoy doing that. Out where I'm at in Vicksburg, I have fairly decent sky, especially to the south. Okay, next. Oh yeah, NGC 4151, the Isoron, which is the other Isoron is the Helix Nebula, is called the Isoron also. So this is up by M51 actually. This is 11 hour of exposure time. 8 o'clock position here. You got NGC 4156, nice little tight spirals going on in there. And then you got the PGC, another little galaxy, a principal galaxy catalog. I've been finding as I get deeper and deeper with the scope that I'm getting all sorts of weird catalogs. I have no idea what they are. So I've been trying to learn the meaning behind at least the names of them, besides, NGC, everyone knows it NGC, new general catalog and all that stuff. But yeah, 11 hours exposure time, luminance, 60 by 300 minutes or seconds is pretty typical for my luminance. And then I do 3 minutes for red, green, blue. I must have ran out of patience with the blue filter, so I cut it short. This? I did not bring that annotation. There is so many galaxies. I mean, we got one up there. That one is a PGC galaxy. It's just some number. I should annotate these. Yep, there's that one. And there's a whole pile of them. One in the bottom, up top. Yeah, they're all over the place. This was actually, the exposure was, and having a fast enough scope, you got the diffraction spikes from the bright star. The core actually has a diffraction spike. The Seyfert galaxy, so it's an active nucleus, so it's a lot of stuff going on. Next.
Just wanted to say the spiral arms look much better on the screen, so get to Pete's Astrobin page and check it out online because it looks a lot better on there.
Oh yeah,
It really comes through better.
ones. Yep. LBN. Here's another weird catalog. LID's Bright Nebula catalog, which is a total lie. This is not a bright nebula. Not many of them are. This was 18 hours of exposure. Yeah. So this is up summertime object. Just another section of the Milky Way. It's just these nebulas are just splattered all over the place. Very interesting, very dusty. So like the Iris Nebula we saw earlier, these things are all over the place. Perfect for mid focal length or even longer ones. 18 hours of exposure times, the LRGB, nothing super exciting. This catalog is actually really interesting. There's quite a bit of it, and it's pretty much all through the sky. So I'm going to start focusing on these. One neat thing was I did find was, Richard, I don't know if you can get the pointer up there. I can't. I'm too short. I'm 6 foot. There's that little spiral that's up there. It's just really neat to see these little background galaxies, especially when you're looking at the Milky Way, where you typically think it's just piles of stars. But a lot of times you can find these little galaxies in there. And of course, I got a real bright star right off on the edge. This was with the first image taken with the new setup. So hard to tell, but the focus never shifted over. Well, this was over multiple nights, but I focused once and the carbon fiber doesn't move at all, doesn't change focus. So I set it once and that was it. So next.
Would this be a cometary globule? Because it kind of reminds me of that famous one that David Malin took where it looks like it's going to eat a galaxy.
Yeah, it is. It's kind of interesting because when you actually go up, it almost makes like a ring. So there's so much more to this. But it's just another dusty, almost like the Taurus molecular cloud along those lines. There's just so much dust in our area.
Right. For this next one, as soon as I saw this online, I thought to myself, Sinclair's going to have kittens when he sees this at
Okay.
Astrophoto Night. So here we go.
I must see M74. Yeah. Yep. This is my last one. I just finished up last week. 16 hours of M74. It's down in Pisces, so it's actually pretty low. So I had to wait for it to clear the chimney at my house, get over to above the the roof line and keep going, and night after night after night. It's a textbook example of a grand design spiral galaxy. No H alpha. The H alpha regions are very prominent. The scene was extraordinary these nights when I took the luminance. The luminance, I should have put the luminance on here. There's so much detail. There's so much depth at 8 hours with an f4 scope. There's so many background galaxies. It's bonkers to do that. And it's actually cropped down because the actual field of view of the camera is actually kind of a bit bigger, but it was nice to look at this in a more cropped version. But it doesn't look like M74. I've looked at it many times through a Dobsonian, especially at, star parties, and they're still, kind of fuzzies. It's a face on, so you get a little surface brightness. I think it's only like magnitude 10 or so. But yeah, LRGB. I thought about going back during the moon nights to get some H alpha, but I'll probably move on to other stuff. Yeah. On my AstroBin site, the detail is, when you actually go to the full res, the detail in here is actually pretty good. Since I upgraded the tube and everything, got everything under control, the best nights I had like 1.5 arc second scene over 5-minute exposures, and I had lots of them. So I had some really sharp frames, and I had some really horrible frames. Some of them were like 4 arc seconds, just because it's Michigan. They're horrible. So Michigan is capable of good skies, but you're lucky when you get them. That's it for this year. Hopefully more next year.
All right. Thank you very much, Pete.
Yep.